Hi. Hi everyone. Um, this is new for me. Let's see how I can do this. So we are reaching the final topic on this our study of design of gears. Okay. So today we're going to be looking at the design procedure for worm gears. We're going to start with the design procedure for worm gears and then solve a couple of problems if time permits. Right. So let's get started. This here, so this is this is what you want to imagine when we're talking about worm gears. Uh, so you have this larger gear and then you have the smaller gear. The smaller gear is called the worm, and so the smaller gear is the one that we want to design. I know usually we have seen pairs of gears and we have tried to find the weaker gear, but in this case the smaller gear, the worm gear, is the weaker gear. Okay. So we're going to be designing only the worm. Okay, we're going to design just the worm. We will design only the worm. We will only design the worm gear. We'll only design the worm. Okay. So let's move. So I'm going to write procedure, design procedure for worm gears. For worm gears. Okay, maybe I just color it, right, like I usually do in class with all those colors of chalk. So that's what we're doing. Okay. So this means that we're going to be looking at a series of steps that we need to follow when solving problems. Okay, so there are 6 steps, and the steps are pretty similar to all the steps that we have seen before, right? So let's write down those steps. Maybe another color. Step 1. Okay. All right. Now, in all the gears that we have designed, we've had to find the weaker gear of the 2 gears, and we designed the weaker gear, right? Here, I just told you the worm is the smaller gear. It's taking the same forces as the larger gear, so we have to design only the worm. Okay, so here the weaker gear is the worm. You can write the worm gear if you want. So we will design the worm. Okay, so we will design the worm only. Okay, so that essentially cuts down one step, so makes things a little easy. So I just write makes life a little easy. Okay, so that's step 1. So let's look at step 2, right? We're looking at step 2 now. Okay. Now, usually what happens here is we're trying to find the module, right? We're trying to find the module. And to find the module, we find the tangential load, and then we find another tangential load. We compare the two tangential loads and find the module. So that's what's going on in step 2. Now I'm going to write that out, right? So we have to find two tangential loads, compare them, and find the module, okay? So here's the first tangential load on the tooth, on each tooth of a worm gear. On each tooth of the worm. Maybe this is too thick. I'm just going to try a step lighter, and then if it's fine, it's fine. Of the worm. Okay, yeah, it seems good. So remember we called those two tangential loads A and B. So let's just do that. Okay, I'm going to find A. Okay, and then I'm going to find B later. Okay, so Ft, this is the tangential load, tangential force, equals 1000 P, that's the power. And if you remember, it was CS, the service factor, divided by the velocity. You know, this equation kind of makes sense. The service factor doesn't have any units. The power has the unit of watt or kilowatt, which is Newton meter per second, right? And you divide Newton meter per second by meter per second, and you get force. So that's pretty cool. Now let's say that this guy is equation 12.7a, right, in the data handbook, and then the service factor is in table 12.8, is in table 12.8. Okay, and so V is the velocity, P is the power. I think let's just go ahead and see those, the equation and the table, right? Let's just do that. So I have the data handbook here, and we're looking at table 12.8 for the service factor. So that guy is here, right? Table 12.8. Let me mark that out. So this is table 12.8, and so we can pick the right service factor. And then we're looking at equation 12.7a, I believe. 12.7a. Okay, so that guy is here. So this is 12.7a. And yeah. So that completes equation A for us, right? So we're done. V is the velocity, P is the power, Ft is the tangential force. Now I need to find the second tangential load. That's what I'm going to do. So the second tangential load, right? So this is based on the Lewis equation. So based on the Lewis equation, we have, I'm not going to write we have, right, sigma D is the allowable static stress times the velocity factor times the face width, right? and then we have this capital Y, which is actually pi times the small y, where small y is the Lewis form factor, right? We will see all this quickly, soon, if not quickly, times the module, okay? And let's number this equation from the data handbook. This is equation 12.53a, okay? You know what, let's just see the equation in the data handbook, because these terms are going to be defined there, right? So we have 12.53a. You guys should also be scrolling the data handbook with me so you get familiar with what's going on. All right, so we have 12.53a. So that's this guy. So we have it here. Here we have, right? And it tells us that y is pi y, and then there are some conditions, and then there's the velocity factor, and so on, right? If you remember, we've used these things before. We've used them. Okay. So I think, right. So we'll keep going, I think. We'll keep going. So this, let's just write down a few things, right? So this allowable static stress is available in table 12.7, right? And formulas were right under, right, I'll just write with equation 12.53a, right? Because it was there. And this width of the face, you know, you've got to choose it somewhere, right? And y is pi times y, right? And this is in, I believe this is in table 12.28c. Let's take a look. .28c. Yeah, you see the value for y, the value for small y for worm gaze is here. It's based on the normal pressure angle. We know that. But there's also some information in table 12.5 and 12.6. So let's take a look at that. See, values of y and values of y, the tooth form factor, that's what. Okay, so you have y, you have number of teeth here. Yeah, so we're going to have to see how to use this, okay? And let's go to 12.53b. I know this, you know, I'm just showing you where all the information is. And when we get to the problems, we will see what needs to be done. So there's also this equation for y here, okay? We might have to use this, okay? So this equation is used if the number of teeth, so I'm just gonna, you know, here's the explanation. So if the number of teeth in the worm gear plus the number of threads is 25 mm length in the worm is greater than 40, y may be determined from this equation. So there's a condition under which you can use this equation. We'll see all this when we get to the problem, right? So let's keep moving. Okay, so what do you have to do? Here you just have to, so let's write this in another color, okay? So compare or equate, right? So it's compare, let's A and B, A and B, to find the module M. Right? To find the module M. So this is what we're going to have to do. So this is step 2. This finishes step 2. Okay. So we can now go to step 3. We can go to step 3. Okay. So I have step 3. I hope you guys are liking this, right? Actually, that kind of finishes the design. Step 3 is kind of the last step, okay? So we can use tables 12.26 and 12.27 to find various dimensions, it's plural. I'm going to say slash proportions of the worm gear. Okay, so let's just take a look at those tables, 12.26 and 12.27. I made a mess of my data handbook. I'm going to have to get another copy or just not save the changes. So I go to 12.27. Yeah, so I have proportions for worm gears here, 12.27, right? And recommended pressure angles and some other worm gear data. I have some other worm gear data. So that, I can use all this because you see the normal pressure angle. So if the pressure angle is given in the question, you can use this, and then you can find the outside diameter using this. You can find the throat diameter using this guy, right? And then you can find the face width. See, B is here. And then you can find the radius. So you can find many things, okay? So this is about half the design procedure. I'm going to make another file for the other half, okay? So I'm going to stop the recording now.